Hello everyone, here in this video we are going to analyze a 2D material, but this model here in this video is something special. I decided to use the Turkish uh, the Turkish flag as the model for this analysis. So for drawing the flag, Turkey flag, first we are going to start in the part modulus, and here in the part modulus you have to come here and click on create part. In this window you can write the name as Turkey bayrak. It's a 2D planar model. Then you have to select here, and it could be, it's a deformable type, and here you have to choose the shell module, and the approximate size you can use 5 and click on continue. You will go to the drawing section, and here you have to draw a rectangle first. Let's say the dimensions are 2 for this side and 3 for this side. Okay, now I have to, now it's okay, and I click done, and the rectangle shape is created here in this part. Now I have to reduce the moon and the star inside this flag. So I have to click on create cut, click this icon. First I have to find the middle of the flag. So so you can see that if I draw the mouse inside this line, there is a point that indicates this point is the middle in this line. So click 1 here and go to the other side. Also here you will find this point, the white point, which indicates the middle of that line. So you can draw these 2 lines as well. Now you have to remove or erase this line. Click done. Now we can find out where is the middle of our flag. After that, you can create a circle exactly like this, and the radius is let's say 0.6, and another circle like this, and let's apply the dimension to this circle as well. This one is 0.5, and the distance between these 2 centers, not this one, sorry, center from here to here is 0.2. Now 2 circles are defined. As you can see, these 2 circles turn to green, which means that the location of these two circles are defined in the plane. Now I have to reduce these the extra lines, and I have to delete the extra lines. You can use the trim icon, this one, and now select all the extra lines like this. Okay, now click on done, and you can see the moon shape created here. Now I have to reduce the star. For sure you know that the star inside the flag of Turkey is a five-sided star, so for that once again I click on the create cut, and now I tried a lot of way to draw the five-sided star here, but the simplest I think is this one. So for that you can draw a circle like this. Now let's say the radius of this circle is 0.2, and now let's draw a pentagon like this here. So I can use some bounds like this, some constraints. So click here on this icon, add constraints, and click on equal lengths. So as you put the shift button, you can select all these lines and click on done. So now you have a pentagon shape here, and now you can trim or delete. Now you can delete this circle here, and simply you also can draw this star shape. And also, once again, using this auto trim, you can delete these lines, Ctrl Z, trim these lines. Okay, now it's okay, and it's done. You would see the shape of Turkish flag here in this video. Now we want to analyze this model. For example, think that this is a plane, and this is a 2D plane stress analysis. This plane is made of, for example, steel, and now we are going to add the material property of this model. So the name of the material is steel, and you can come here to elastic and 200 gigapascal, which is 200 E9, and the Poisson ratio is 0.3. here we had a space in the name, so now we create the material. So now we have to create a section. Our section is solid and homogeneous. Please be careful to don't select shell here, because the shell section is something else and is not 2D analysis. So click continue, and you can click on the plane strain and, for example, add the thickness equal to 10 millimeters. So let's say 10e minus 3. Okay, now we have to assign this section. Assign section number 1 to our model. Okay, now I'm going to the assembly and I bring my model here into the assembly module, and let's change this instant type to independent and click on OK. Now I would go to the step module, and here I'm going to create a step. So it should be a static general analysis. Click continue. You can click on nonlinear geometry if you think that your deformation is large, but if your deformation are not too large, you can neglect the nonlinear geometry and click off. I'm not going to change the other options here. Click OK. Now I'm going to the load module, and here in the load module, let's apply the boundary conditions. The first boundary condition, you click on display rotation and continue. Click this line, and here in this line, let's say that the x displacement is 0, so you have to click on U1 and apply 0 to this U1. Also, I am going to bound this node, this point, because it may move or it may have a solid movement in the y direction. So once again I click on boundary condition and displacement rotation, and now I am going to select this point, done, and this time I apply U1 and U2 equal to 0. Now it's okay. As a load, let's think that this iron flag, this steel flag, has a pressure, a tension in the x direction which acts on this line. So I have to click on create load, then pressure, click continue, choose this line, done. Let's say 2 kilonewtons, 2 kilopascals. So we have to E3 Pascal. Okay, since it's pressure, we have to edit and add here minus 2 kilopascal or minus 2000 pascals. Okay, now I'm going to the mesh module. So here you have to define define your seeds, the displacement, the seed size or the element size. So here you can click on seed part As a default, it's as a the approximate global size of the seeds is 0.15. If you want to check if it is okay for you or not, you can click on apply. As you can see, these lines could be only one element, which is not good for us. Then I reduce 1/3 and let's say 0.05 for the approximate global size of the element. So click on apply, and now you can see that we have 1, 2, 3 elements in the star lengths, so it's okay for us. Click on OK. Now let's mesh it. Click on mesh part and say yes. Now you can see the elements which distributed all over the flag. And now I'm going to assign element type. So I click the assign element type and select the whole model, and now I am choosing the plane stress, which is true. This is the analysis that we considered before as a plane stress analysis. Let's say the linear geometric order is okay, but you may know that if you change the geometric order, your element shape would be something else. For example, for linear you have CPS4R, which is a 4-node linear plane stress element, but if you change to quadratic, you would have another type of element, an 8-node by an 8-node by quadratic plane stress element. So it is you have to check which one is close to your analysis, close to your real answer. But here is a tutorial, and we choose linear to do not pay a lot on the runtime. Click on OK. Now we can go to the job, and here we can create a job. Continue. OK. Now open the job manager window and submit. You see that our analysis submitted, and now it goes and now it is going to the running status. It shouldn't take a lot of time. Yes, it's completed. Now I'm going to the result and the visualization module. So you can see the deformed shape of this flag, but you have to know that this amount of deformation is not real. You have to come here on the command option. Here you can click on uniform, and as you can see, it is 5.0 E6. It means that the scale factor of the deformation that you can see here is 5.0 E6 times more than real. So if you change it to 1, you can see that the deformation is almost 0 for that amount of load. Another thing that you can change here, you can uh, you can click on free edges and apply it to neglect showing the elements itself. And this is the deformed shape, sorry, this is the von Mises stress contours on the flag steel plate, which our load comes here, and you can see the maximum stress comes here in these two sides if you apply that load in this direction. So we can see another results like strains, which is similar, almost similar to the stress von Mises stress, and you can see the maximum amount in this size, or maybe you want to see the magnitude. You want to see the magnitude of the displacement by selecting U, or reaction forces. For the reaction forces, it's better to go to the plot symbols on deform shape and click here. You would see the deform shape. You would see the reaction forces here in this side. And I hope you enjoy this video.